Hello, welcome back, PlayBASIC coders. Here we have a quick question on the forum about doing ray casting. There's a few examples on the board that do this. I won't go over them. In the help files, there's one way that we'll look at now. Actually, there's an example at the bottom there, and what it's doing is it defines the outer edges of what the impact zones are. In this case here, we're using a bunch of rings. And then we're casting a ray out from the mouse out into this world. If it impacts the world, we return to the collision point. If it doesn't, it just returns nothing. So that ray hasn't struck the world as yet. That's fine for sort of abstract shapes, but in a classic Wolfenstein sort of situation, we have a map. So let's have a go at this. Over here, I've taken the same code, same basic framework, and add a simple 2D map, just using to represent each block as just a 1, a 0 is a nothing in that block position. That's our data. We'll go through the code, setting up screen mode. Our map is 16 by 16. Create an array to hold that. Read the data in. It's stored as a bunch of strings at the end of the file. So we'll read the local data in, decode it as we wanted, as in a 0 meaning there's no tile present, and a 1, well in this case anything other than 1 would be that that's some kind of tile index. Load them all in, get the world space, create a camera, create a new world, put some bounding lines around the edge of the world so we're not going to run off way outside the world constraints. This is for collision worlds, by the way. And then we just start running through our little tile map, and block by block, just running through across each row. Is the block, has it got something there? If it's empty, we just skip the process, go to the next block. If it's not empty, we work out the coordinates for the top left, position on screen, and the bottom right. In other words, kind of up here and say down here, that little rectangle sort of, or square of the tile. We do a slight optimization here. Since we're taking each tile and drawing the bounds of that tile as line fragments that we're going to run collisions against. When we have tiles next to each other, or blocks next to each other, the edges that are invisible or impossible to reach. So if you have two blocks beside each other, there's going to be a shared edge amongst those blocks. So we don't need to have elements between them. We can just eliminate those and just have the outline of the shape rather than all of the intricate parts of the shape. We're doing that from the top, the bottom, the right. So we're just checking to see if is there something, in this case here, the top for example, we're going, is there a block above us, directly above us? That would mean the roof, or the top line, and the bottom of the block above us don't need to have a line drawn for a collision in those zones. Same along the bottom, same along the left side and the right side. That's pretty much it. The rest of the code is the same as the code in the example. Literally, it's exactly the same. So we're setting up a scene, doing a capture of this. So we're taking the world fragment data, which is a bunch of lines which we're using to run collisions against. We're copying that data into the scene as viewed through my camera. That world can just be a large data structure, and we're saying, hey, grab the data that's in front of the camera at this coordinate within that world. So the world can be much bigger than the screen, but here I haven't bothered. Anyway, we grab the mouse's coordinates on screen, and we cast out rays from that coordinate in screen space out into the world. we were just plotting polar coordinates around the cameras. So imagine sort of standing in one direction and then moving in, say, 5-degree increments, and then firing a shot out, stepping another 5 degrees, firing a shot out. So we end up with this kind of ring around the mouse's origin point. So here we're just using ray intersect world. We're just telling it what world to run intersections against, where this ray starts and where it ends. If it returns true, we hit something, then we get the intersection coordinates and draw a circle. If not, we just draw the line as it was. Let's run it. So see around the outsides up here, these are all tiles, but because the shared edges have been removed, we don't have those lines in them. Yeah, that making sense? We don't have so we're reducing the number of lines to run collisions against. So that where our little mouse is here, looks like we're sort of hovering through or running a torch through a space, which is pretty much what we need actually. There I'm stepping inside the tile. So the way ray intersections work, or collisions work in this case, is that the wall fragments are one direction. They face a certain direction. So if we are facing the wall, we can impact it. If we go behind it, we cannot impact it. So once we go outside the bounds here, we have no collision in this demonstration. So in that regards, you would use the map and then limit the player's movement based on the map. Probably, PB does actually have sliding collision built into it for sprites to work with collision maps. It's a very old feature. It's not the most intuitive thing in the world, but it does work, and you can make sprites just slide around the world any way you like. So in our example here, you see how some rays impacting the world, like the rays above us here are impacting the wall here, but the rays off to our left are not reaching the far wall. So now they are. In those cases there, you would do a recast of those rays and step the distance out longer. In that case, you could actually make the visibility arc, or our distance that we're casting our rays, we make that smaller anyway, maybe 100 units or maybe just 150 or something like that. And if they don't hit something, then we cast again at 300. And if that doesn't hit something, we cast again at, say, double again, 600 or something like that. It's pretty cheap to do. It's easy to set up. It's confusing, but you can do the same thing in PB with shapes, by the way. You run ray intersections against shapes. So you could just have these wall fragments here as a shape, and then run intersections against the shapes, as you would like if you had like a three-dimensional scene of objects. You'd run ray intersection against them. Probably sort them first, or work out what the nearest ones were first, because you're more likely to hit those ones. And then if you don't hit them, step through the next one out. Do we hit that? Yes, no. If we don't hit it, we step to the ones out further, etc. Anyway, that's our little ray intersection demo. Hope you find it useful. I'll post the code in the response below. Thanks, and see you later. Bye.